Today we're going to look at a concept which you all did in Algebra 1, hopefully you did, which is factoring. We'll be factoring quadratics. And I'm just going to do a couple of problems to make sure that you understand or remember how to do factoring. And factoring is just a concept of rewriting the expression as a product of its factors. For example, if you had x squared plus 9x plus 20, when we're asked to factor, that means we're going to rewrite it as a product. Product means multiply. So basically we're trying to find out what did we multiply to get x squared plus 9x plus 20. In actuality, to break it down, we are looking for two numbers that multiply to give you 20, but they add to give you 9. So when you're doing these, some of you all are going to be really good about finding your factors if you know your factors in your multiplication table, and then some of you all, it may take a moment to get there. So the two factors that I'm thinking of for 20 are 4 and 5, because if you multiply 4 times 5, you get 20. But if you add 4 and 5, you get 9. And the way that you write it, it'll be x plus 4 and x plus 5. And then you can always check your answer by multiplying this back out using our FOIL method. And then you should get back what you started with. Let's try another one. Now we need two numbers that multiply to give you negative 72, but add to give you 14. Now 72 has a lot of factors, so you have to be careful with numbers like that. And it's just basically trial and error until you find the ones that work. You just know that they are 14 units away from each other. And when you multiply them, you have to get a negative. So you know that one number has to be negative and one number has to be positive. And the larger number will take the sign of the 14. And so when you figure it out, the only ones that work are 18 and negative 14. So the 18 has to be positive and the 14 has to be negative in order to make a positive 14. But when you multiply them together, I'm sorry, I keep saying 14, but it's 4. And when you multiply them together, you'll get a negative 72. So it'll be x plus 18 and x minus 4. The order really doesn't matter, just as long as you put the positive with the larger number, which was the 18. Now sometimes you may see something like this where the x squared has a negative. And what we're going to do is we're going to factor out a negative. So when you factor out the negative, you're basically dividing everything by negative 1. But you have to show your factor. And now we're looking for two numbers that multiply to give you 12, but add to give you negative 13. And usually when they're like 1 away from each other, that means that the two numbers have to be that number and 1. So we have 12 and 1, and we know 1 has to be negative, 1 has to be positive. Here again, the larger number takes the sign of B. And so, but since we need a positive 12, that means both of these have to be negative. So it'll be x minus 12, x minus 1, and the negative has to stay on the outside so that we get back what we started with. All right, I'm going to have you to try these 3 guided problems and make sure you remember how to factor. Pause the video and then we'll check our answers. Okay, example A, we had to find two numbers and multiply to give you 40, but add to give you 14, so it was 10 and 4. B, we had to find two numbers and multiply to give you 30, but add to give you negative 11. So that was negative 6 and negative 5. And C, we had to factor out that negative. You always want A to be positive, and then you make sure you divide everything by that negative 1. Then you find two numbers and multiply to give you negative 32, that add to give you negative 14. So if you got them all right, you're doing great so far. Sometimes when you're factoring, you may have to find a GCF or greatest common factor first before you actually factor. So I always say that you look for your GCF first, and then you can proceed with factoring. So let's look at this first problem. 6n squared plus 9n. Notice there are only two terms now. So I'm going to look at what these two have in common, which is a 3n. And then you factor out a 3n. And it's kind of like you are doing backwards distributing. So you're trying to figure out what times 3n will give you 6n squared. Well, that would be 2n plus what times 3n will give you 3n, or 9n. That would be 3. And that's as far as you can go. And then you may have one with 3 terms, like this. And you look at all 3 terms to see what they all have in common. And I notice they all can be divisible by 4. They could have been divisible by 2, but you want to look for the greatest. So you take out a 4, factor out a 4 here, and factor out a 4 here. So that way if you distribute the 4 back, you'll get back what you started with. Now on our answer, you have to leave the 4 on the outside, so it will bring you back to what you started with. So now I need two numbers to multiply to give you negative 14, but add to give you 5. So I know the bigger number has to take the same sign as the 5, and the other number will be minus, so we can get a negative 14, which would be 7 and negative 2. And then you're done. Okay, now I want you to try these 3 problems, and then we'll check our answers. Okay, for the first one, the only thing we could do is factor out the 7. That's as far as we could go. Example B, we could factor out a 9 first, but then we can go further to find two numbers to multiply to give you negative 2 that add to give you 1. Then the last one, the only thing we could do is factor out a 4, because we can't find two numbers that multiply to give you positive 3 but add to give you 2. So sometimes the only thing you can do is a GCF. Now so far we've been doing quadratics where A has been 1 or negative 1, or we could factor out a common factor. And in this particular case we can't. So we factor these a little differently. Now some people like to do trial and error where they just figure out the two factors that make it work, so you multiply it back out. And then some students find that that's very time consuming. So another way that we do it is we use what's called grouping. And when you do grouping, you first have to multiply the first number and the last number, and we get 24. And we find two factors of 24 that add to give you 11, which would be 8 and 3. Actually, it would be 24x squared, so it would be 8x and 3x. So what you're going to do is take the 8x and 3x and replace the 11x. So it'll look like this: 2x squared plus 8x plus 3x plus 12. And you want to do it so that you end up with 4 terms. So these two in the middle should add up to this number here. Okay? Then when we do grouping, we're going to group the first 2 terms and the second 2 terms and use our GCF method. Well, the first 2 terms have a 2x in common, so that'll leave x plus 4 plus. The second 2 terms have a 3 in common, and that'll leave x plus 4 again. You want to make sure that these 2 factors are exactly the same. And if they are not, then you did something wrong. So, since both of them have an x plus 4 in common, that's one of our factors. And the other factor comes from the 2 terms that you pulled out as your GCFs. 2x plus 3. So this is the GCF of both terms, and this is what they have in common. And it doesn't matter the order. And that's probably one of the easiest way to do it when A is not 1 and you can't pull out a GCF. But as I stated before, you can do trial and error till you get it to work. Let's try another one. 4x squared minus 4x minus 3. Okay, remember you want to multiply your first and your last term, which is negative 12x squared. And you want to find 2 terms or 2 numbers that multiply to give you negative 4x. Which would, one has to be positive, one has to be negative. So 12, we can use negative 6x and positive 2x. Those will replace your negative 4x. So you'll write 4x squared minus 6x plus 2x minus 3. Okay? Then you're going to do grouping again. The first 2 terms have a 2x in common, and that'll leave x or 2x minus 3. And the only thing that the next 2 have in common is a 1. And that leaves 2x minus 3. Okay, you always want to check to make sure those are the same. That's what they have in common. And then our GCF terms we took out, which were the 2x and the positive 1. And there's your answer. Okay, I want you to try these 2 guided problems and make sure we understand this before we go further. And then we'll check our answers. Okay, for example A, I had to multiply 4 times 3 and got 12x squared. I needed 2 factors to add to give me 7x, which is 3x and 4x. I replaced the middle term, the 7x, with those 2 terms, and I set it up for grouping. Now the first 2 terms had an x in common, and I was left with 4x plus 3. And the next 2 terms had a 1 in common, and I was still left with 4x plus 3. So that's how I know that my factoring was done correctly. And the one they had in common became a factor, and the GCF, which is the x and the 1, became a factor. Example B was kind of similar because we had a 12x squared, but this time we had to make negative 7x. So it was negative 3x and negative 4x. I'm glad we had a negative because what I want to show you in this one is when you do grouping with the first 2, you had an x and you're left with 2x minus 3. The second 2, I had to take out a negative 2 because if I didn't, it would have been negative 2x plus 3, which is not what the first term had. So you have to be careful to look at your signs to make sure you take out the correct term so that both of your factors are exactly the same. So 2x minus 3 is what they had in common, and x minus 2 was what we took out as the GCF. And there are your two answers. Okay, we'll try these last two. These are special kind of factoring. And what you want to do first, again, here is make sure you pull out a GCF. So with the first one, they all have a 4 in common. And this is when they say factor completely, if you ever see that, what they're going ahead to let you know that there's probably a GCF, and then you probably can go further. So we need two factors of 9 that give you -6. The only two that will work are -3 and -3. Now we call this a perfect square trinomial because you can rewrite this as x minus 3 squared. So if you don't want to write it out twice, you can just put the square. So that's what they mean by a perfect square trinomial, because tri means 3. Now this second example, there's no common factor, but if you recognize, they are perfect squares. So you have to figure out what two numbers will multiply to give you 25x squared. Well, that's 5x and 5x. And then what two numbers multiply to give you 49? Well, that's 7 and 7. The difference from this one and the previous problem is we need a -49. So one of your factors has to be minus and the other one is plus. So you want to make sure you watch out for those perfect squares. Because if you don't recognize them, you may try to multiply 25 times 49, and you're going to get a huge number. So let me leave you with two to try. Okay, try these two, and then we'll check our answers. Okay, these two are a little tricky. For example A, there was no common factor. However, 64 and 1 are perfect squares. And the square root of 64 is 8x, or 64x squared, and the square root of 1 is 1. Since we need a positive 1, that means that they, and a -16, they both have to be negative, because -8 and -8 make -16. Or if you want, you can write it like 8x minus 1 squared. So either one of those is correct. Example B did have a common factor, which was 2. So we had to factor out a 2 first. Forgot my parentheses. And then that left us with 16x squared minus 81. 16 and 81 are perfect squares. However, since we needed a -81, one factor had to be positive and the other negative. And so that's factoring. So really, factoring doesn't require a lot of work. It does require you to think about your factors and your perfect squares, and then you should be able to get the right answer.